Hello everyone, my name is Harsh. Today I am going to show you a simple Arduino project where I control the two LEDs using a push button and an ultrasonic sensor. The green LED will be toggled with the button press while the red LED turn on when an object comes closer to the sensor and off when it's not. This project demonstrates both interrupts and sensor-based control with the Arduino. This is my hardware setup. Here I will explain how everything is connected and the components which I have used for this project. I used the Arduino Nano, an ultrasonic sensor, one push button, one green LED and one red LED, resistors and the jumper wires. Now the push button is connected to the pin D3 with the internal pull-up resistor enabled. The ultrasonic sensor uses pin D4 for the trigger and pin 5 for the echo. The green LED is on pin 9 and the red LED is on pin D8. Ground and 5 volt from the Arduino are used to power the button, LEDs and the sensors. So the green LED responds to the button and the red LED responds to the ultrasonic sensor. Now I am going to explain the main functionality of my code. But before moving further, let's have an eye on my code once. Now, the first step is pin definitions and variables. At the top, I define all the pins and also create a flag for button press. The volatile keyword is used because the button press will be handled using an interrupt. The second step is interrupt setup. In the setup function, I attach an interrupt to the button pin. So whenever it is pressed, a flag is set. This ensures the button is detected instantly without being missed. The third step is green LED logic. Inside the loop, if the button flag is true, we reset it and toggle the green LED. This makes the green LED behave like an on-off switch each time we press the button. And the last is ultrasonic sensor logic. Here I use the ultrasonic sensor to measure the distance. The trigger pin sends a short pulse and then we measure the echo using pulse in. The distance is calculated in centimeters. If the distance is less than 20 centimeter, the red LED is turned on, otherwise it stays off. So the red LED behaves like a proximity indicator. Now I am going to show you the live demonstration of my project. The first main step is to select our board and port, which is Arduino Nano 33 IoT, and the port which is connected to our Arduino Nano, and then save it using Ctrl plus S, and then click on this tick button to compile our code. When the compiling is done, we are going to upload our code. When the uploading is done, I am going to open the serial monitor. Here is my hardware setup. You can see this is the green LED and this is the red LED. Here is our push button. Now, when I place my hand at a distance of 20 centimeter on the ultrasonic sensor, the red LED turn on. And you can see the live readings which are displaying side by side on the serial monitor. As you can see, when I keep my hand far away from the ultrasonic sensor, the red LED stays off, which means our ultrasonic sensor and the LED which is connected to that are working perfectly. Now let's check our green LED using the push button. Here is our push button. When I press the button, our LED turns on, and when I press the button again, the LED stays off, which means our LED is toggled on and off when the button is pressed, and you can see the readings displaying on the serial monitor, which means our project is working as expected. So the conclusion is, in this project, I successfully combined the interrupts with the sensor-based input. The push button shows how interrupts can make input detection fast and reliable, while the ultrasonic sensor adds interactivity based on the distance. This project can be extended further. For example, you could use the ultrasonic sensor for the obstacle detection in a robot or the button to control the multiple functions. Thanks for watching, and I hope this gives you a clear idea of how this project works.